Okay, so one of the things we talked about, which you're going to see in 10.6 in my math lab on the worksheet, is something like this. Let's kind of review this. So remember, this is section 10.6. And that's where we talked about functions. So if f of x is negative 3x squared minus 2x plus 6, let's say. And remember, that's function notation. That's function notation. F of x means the same thing as what letter? Y. The y that you used to. So whenever we write in function notation, though, there are many things you can do with that function notation. So you can just say something like this: find f of 2. So when you ask to find f of 2, now remember that of here, the word of does not mean to multiply. So that f of 2 means what is the y value when x is what? 2. And so to find f of 2, what would you do in this problem?
Replace x's with 2.
Yep, replace x with 2. And so you'd say, well, that's going to be negative 3 times 2 squared minus 2 times 2 plus 6. And then you just use the order of operations. So you don't have parentheses here that you would. The parentheses, remember, please see my dear Aunt Sally. In these parentheses, it's just a number 2. So there's really no parentheses for you to do. So what's the next step? Exponent. So it's 2 squared. 4. Remember, this is 4 right here. And then 4 times a negative 3 is a negative 12. And then what's negative 2 times 2? And then plus 6. Y'all agree that that's what I get? All right. Now, do addition subtraction from left to right. Mistake people do is they want to say 4 plus 6. 4 plus 6 is 10, and that's not correct. So do it from left to right. What's a negative 4 and a negative 12? And what's negative 16 plus 6? Negative 10. So f of 2 equal blank, you'll put what? Negative 10. Now remember, one of the, I think it was on the worksheet I've already given you, I can't remember, but one of the questions would be, given this, what's that ordered pair right here? Now that's the answer, but what's the ordered pair? 2 comma negative 10. My x value is 2, my y value is negative 10. So the ordered pair would be 2 comma negative 10. All right, so that's one of the things you have to be able to do is evaluate functions. Okay. All right, and then remember the last class period, we talked about finding domain and range. Find the domain and range. So for example, I'm doing this by hand, but let's suppose you had this graph. It looked like this. And you want to find domain and range in interval notation. Okay, domain and range in interval notation. Notice I'm not giving you any ordered pairs at this point, so I'm going to ask you, without knowing anything about the ordered pairs, which of these, domain and range, can you tell me right away?
Domain's going to be your x values.
Huh?
Domain's going to be your x values.
Well, yeah, the definition of domain is a set of x coordinates, and definition of range is a set of y coordinates. But without knowing anything about the coordinates, which of those can you tell me right away? The domain. You know the domain right away. What's the domain? Negative infinity to infinity. Because as you go from left to right, remember we talked about that, as you go from left to right, remember I use a ruler, as you go from left to right, do I get a point on that graph? Yeah, I mean, it's way up there, so it's from negative infinity to what? Positive infinity. But at this point, can you tell me the range? No. Why can't you tell me the range with what we have? You don't know that vertex. So I have to give you a coordinate. So let's say this right here is 1, 2, 3, 4. And this is negative 1, negative 2, negative 3. All right, what will be the range? Negative 3 to what? Positive infinity. So remember the range, you go from the negative part of the y-axis to the positive part. So I start touching the graph when I get to what y-coordinate right here? Negative 3. So it's negative 3 to positive infinity. And remember, for negative 3, what must I use? Bracket. For infinity, what do I use? Parentheses. Okay? All right, so that was a quick review from what we did the other day. Now go ahead and take what I just gave you. All right, so the same graphs that you had. And the first part says determine the domain and range using inequality. What we did last time, we used interval notation. And on the worksheet, you're going to use interval notation. But on MyMathLab, they've used both interval and they use inequality. So we got to talk about the inequality here. All right. So let's go to let's do number 5 first. Number 5. Go to number 5. Okay, let's talk about the range in number 5. What's the range in number 5? Using interval notation. So we do this. Interval notation, the range. What's the range? Interval notation.
-7, positive infinity.
Yep. So you're going from bottom up. So you start touching the graph when y is -7, bracket, infinity. So that's interval notation. Let's talk about inequality now. Okay, so listen carefully. When you talk about range, the range is a set of which coordinates? Y. According to what we just wrote here, what's the smallest y coordinate? -7. So you're going to say this. Y has to be bigger than or equal to what? Yeah. Y has to be bigger than or equal to what? -7. So that's inequality. So you're going to see that in MyMathLab. It'll be listed as multiple choice, though, in MyMathLab. So some of it will be interval notation, some will be inequality notation. But make sure you understand that these two mean the same thing. -7 to infinity bracket means the same thing as y is greater than or equal to -7. Okay? Let's do the domain. What was the domain in interval notation? Negative infinity to positive infinity. On MyMathLab, in terms of inequality, you really don't write this as inequality because negative infinity to infinity implies which numbers? So which numbers? All real numbers. So MyMathLab is going to be listed as all real numbers. That's the way it's going to look. So you're going to have some choices that are inequality, and you're going to have some choices that are interval, and you have some choices that just says all real numbers. If it's all real numbers, it implies the same thing as negative infinity to infinity. You can't write that as an inequality. Okay? All right. Number 6. What's the domain in number 6? Let's do domain first. Interval notation. Or I can write it as what? All real numbers. But if I say, and I do on the worksheet, if I say on the worksheet, I also do this on the test. If I say on the worksheet of the test, interval notation, then you have to say what? Negative infinity to infinity. On MyMathLab, there's also going to be some problems where you can just say what? All real numbers. Okay, so any real number is in the domain. Negative 2.6 is an x value. Negative 2.948 is an x value. What's the range? Interval notation. Negative infinity to 6 with the bracket. Now, so remember the largest. Now you got to see how to write this though. So I'm gonna ask you, what do you think the inequality notation would be? Less than or equal to what? 6. But you got to say what letter? Y. So y is less than or equal to 6. If you think it's anything else, let me know so I can tell you why it's not. But that means y is less than or equal to 6. Nothing else. You cannot say y is greater than negative infinity because you can't use negative infinity as that number because it's not a number. Negative infinity is not a number. Okay? Yes?
So if the arrows are pointing down, it would be less than, like, no matter what.
Okay, so he's asking if the arrows are pointing down, then you kind of look at your vertex, and so all my y values are less than that, right?
Yes, sir.
Okay, y'all understand that? Right here, my vertex is at the bottom, so all my y values are what? Greater than that. So yeah, you can think of it that way.
Okay.
Yep. All right, let's look at, now knowing about our real numbers, let's go back to number 1. What is the domain in number 1 in terms of interval notation? Remember, that's a line. What's the domain? Okay. What else can you say if I don't specify? Oh, real numbers. What's the range? Interval notation. Going from bottom up. Yeah, because the arrow, right, keeps on going. So negative infinity to what? Positive infinity. What else can you say? Oh, real numbers. Okay. All right. The circle. Now remember, some of these are functions, some of these are not. Okay. All right. Now number 2, is that a function? Not a function. We talked about that last time. It's not a function, but we can still talk about domain and range. In terms of interval notation, what's the domain? You go for along the x-axis. Where do I start touching the graph when x is what? And I stop when x is 7. So bracket -3, bracket 7. All right, now, notice that in the 2 that we did earlier, we said y was greater than and y was less than, right? Here, my x values are between what 2 numbers? -3 and 7. So here's how you write this. You got to remember something from last semester. You're going to say, now remember, domain is x, right? You're going to say x is less than or equal to 7. That's what this is, correct? At the same time, it has to be bigger than or equal to what? -3. So that right here means this. So all my x's are between what 2 numbers? Think about what this says. All my x's are between what 2 numbers? -3 and 7. And why are there equal signs here? Because this is what? Bracket. Bracket. Okay? What's the range? Interval notation. -4 all the way to what? 6. Remember, you always go from smaller to larger. Now, using that same idea with domain, now remember the range of your y's. So you can say all my y's are between what 2 numbers? -4 and 6. You can say -4 is less than or equal to y, is less than or equal to 6. So that's your interval notation. I'm sorry, that's your inequality notation. Okay? All right. Number 3. Remember the horizontal, and number 4 is the vertical. For number 3, let's talk about the domain first. What's the domain in number 3? Along the x-axis.
Yeah.
-infinity to positive infinity. That's your domain. What else can you write it says? Okay, let's talk about the range. So remember when we talked about this last class period, you can't write that as an interval because an interval is where you have an infinite number of coordinates. My range is just one number. What was it? 5. And we wrote it as this is how we wrote it. With the brace? Okay, that's how we wrote it. On my math lab, you could also see it written like this. So remember, this says that my range is only what? 5. And the range is what letter? Y. So you're going to say Y equals 5. So my Y value is equal to only what number? 5. All right, so Y equals 5. That's your range. So when you do my math lab, make sure you have this in front of you as you're working it. Number 4. What is the domain in number 4? -6. So previously, now you don't write it as an interval because it's just -6, right? So you wrote it as a brace with -6 as set notation. Remember that? Now you know you can also write it as what? X equal -6, domain of your x's. What's the range in interval notation? Good. Or real numbers. Okay. So that's number 4. All right, we did 6, 5, and 6. All right, number 7. What's the domain in interval notation? Yep. What else can you write it as? Okay. What's the range? Interval notation. Now be careful. You go from, you look at your Y values. What's the range? Look. Yeah, so remember, use the rule if you got to. I start touching the graph of this vertex, right? My range of my Y value. So what's this Y value, though? What's this Y value? 2. So 2 to what? Infinity. How would you write 2 to infinity as an inequality? Be careful. Always put Y first. Is Y going to be between two numbers? Is what I'm asking. No. So you're just going to say Y is either less than or equal to. You can say Y is greater than equal to. Y is what? Greater than equal to what? 2. That's what that means. Number 8. What's the domain? Okay. What else can you write this as? All right. What's the range? -2. And that it's got to be listed like that. -infinity to -2 with the bracket. What is that as an inequality? Yep, y is less than or equal to -2. That's what that is. Okay. All right, number 9. Okay, now number 9, remember 9 and 10, those are a finite number of points, so you can't write that as an interval. So in what we're talking about here, you're just going to use set notation. So you can do it just like we did before. You're just going to say domain, because it's just a finite number. And then we just said the x-coordinates. What are these x-coordinates? -6, -4, -2, +2, 4, 5, and 6. Right. Now you wouldn't say y equal -6, y equal -4, y equal -2. I mean, you could. I mean, you can say that, but it's just too many y. I'm sorry, I did not mean y. I meant x. X equal -6, x equal -4. There's just too many of those x equal x equals. The only time you want to say x equals when it's one or two of those. So that's all in my math lab. If they give you, and I think they do give you one, it'll be listed like this, like that. What was the range?
6, 5, 2, and -2.
Yeah, because you had -2 listed many times, right? All right. Now, was 9 a function or not a function? Remember what that was? Was not a function or not a function? It was a function because no matter where you draw that vertical line, it intersects the graph once each time. Number 10 was what? Not a function. And the only place that made it not a function, made the whole thing not a function because of where? When x was what? -2, because -2 there, how many y values? 2. Okay, good. All right, what's the domain in number 10?
-7, -5, -2, +2, and +5.
So -7, -5, -2, +2, and 5? Okay. And then what was the range?
7, 5.
So this y value is -2.
7,
This y value was
-2, -5.
-5. This y value is 3 and 3, but we only listed once.
Sorry, this is 3.
Okay, we only listed once. All right. Okay. All right. Now, the other part of my math lab is going to ask you this. Go back to the first one. Now, number 1's a function, right? Do I read number 1's a function? Okay, so I'm going to ask you this. Now, you got to look at yours carefully. Look at your paper carefully. And I'm going to have to pick one that comes out nicely. So I'm going to ask you to tell me. Oops. I'm looking at the wrong screen. All right. So I want you to find, let's call this function f. I want you to find f of -5. I want you to, and then equal blank. So f of -5. So when we did f of -5, you were given the function equation a while ago and last week. Now you're given the graph and you want to find the value. So you have to find f of -5 using a graph. But remember, what does f of -5 mean? If x is what? -5, what is the y value? Can you tell me on this graph where that point is? -5. When x is -5, you got to go down here and tell me what that y value is. See it right here? That's what they're asking. So what's that y value? -5. That's what they're asking. Let me see if I can find another easy one. Okay, f of 4. What do you think f of 4 is? Look at your graph. Very good. So the question is, when x is 4, what's the y value? So you got to locate that point. So when x is 4, the point of the graph is here. You agree? And so what's that y value? 2. All right. So that's reading a function value from the graph. Earlier, this one I did right here, where I said find f of 2. That was given the equation, find the function value. So that you just plug numbers in. Here you can use a graph to locate the value. I can't talk about functions here because this is not a function. All right, is number 3 a function? Yes. So let's find, and this time let's call it g. So I'm going to say find g of, let's say, 4. What's g of 4, do you think? Say it again? 5. Because when x is 4, my point on the graph is here. And so what's that y value? 5. In fact, my y value is always going to be what? 5. That's what we talked about the range, right? Your y value is always what? So if I want to, if I ask you what's g of 100, you don't see x equal 100 here, but it is on the graph, right? What's g of 100? 5. That's what that means. My y value is always equal to 5. Is number 4 a function? No, so I can't talk about functions here. All right, go to number 5. Is number 5 a function? Yes. So let's see if I can do one there. All right, let's find g of 4. What do you think g of 4 is? -7. In fact, that's your vertex. So g of -4 equals -7. Y'all agree? Mm-hmm. Let's see if I can. Okay, here's what we can do that you can easily do from your graph instead of having to estimate. Let's find g of 3. What's g of 3 on your graph? -6? Okay. All right. All right, so you understand how to read it from the graph? All right, the number 6, let's do one, let's find h of -6. What do you think that y value is? Yeah, so it's about here. So let's take 3. Is that correct?
Yes.
Okay. Let's see what I can do. Let's go to number 7. Let's find f of 1. What's f of 1 here, number 7? So when x is 1, what's the y value? You can all locate the point. Make sure you can all locate the point.
7.
That's the point right here. So my y value is 7. So f of 1 is 7. Let's go to number 8. Let's find f of -3. Locate the point. -6, good. Y'all agree?
Yes.
All right, you're going to see this in my math lab and on the worksheet. Is number 9 a function? So we can talk about that. So I'm going to ask you to find f of 2. What's f of 2? -2. What about f of -2? Nope. +6, right?
Yes.
When x is -2, what's the y value? 6. All right, someone said 2, so be careful. F of -2 is 6 because when x is -2, that's the point that goes with it right here. My y value is 6. What's f of -6? +5. Y'all agree? So when x is -6, this is my point. My y value is 5. Okay? Is number 10 a function? No, so I can't talk about functions there. Okay, so any questions on this? Okay? All right, so, I forgot to do number 11 and 12. None more functions, but we can just talk about domain and range. All right, so let's talk about domain here. In interval notation, what's number 11? For domain, it's going to be careful, domain go along the x-axis.
Yeah, -5 to infinity.
Very good, -5 to infinity, y'all agree? What is that as an inequality? Yeah. Oh, I'm sorry, I'm looking at this and not this. Okay, let me go back. All right. So what is the domain here I'm sorry, is it inequality?
-5 is less than or equal to x is less than or equal to infinity.
You can't have infinity in an inequality notation. X is what? Greater than or equal to -5. Because that's what that says. -5 is my smallest x value, so all the other x values are bigger than that. What's the range? Going from bottom up, -infinity to +infinity. How else can you write that? All right. Number 12, and we can't talk about function here, nor with number 12, but we can still talk about domain and range. What's domain in number 12? Remember, you go from left to right. Yep, all the way to what? +4 with a bracket. Now, what is that as an inequality? X is what? Less than or equal to 4. Okay, that's what that is. X is equal to 4. What is the range? Or as an inequality? I'm sorry, interval notation? Or you can say all real numbers. Okay. All right. Okay, so you have enough information to where you can do my math lab. So I'm going to assign my math lab for section 10.6. Now here's the worksheet that's going to go with it. So it looks like this. So look at this carefully. So this is you turned in when's 10.6 part C due? Next week?
January 31st.
Okay, so that's this Thursday? Okay. So this will be due a week from today, so on the 5th. Oh, let me do one like I forgot to do this one. All right. Write this example. All right. So I'm gonna have this set of ordered pairs, and let's say there are 4 ordered pairs. So let's say I have the ordered pairs 3, -1, 2, 6, -4, 8, and then the last ordered pair in this set is x, comma, x, comma, 7. All right, so write this down for right now. So you have this finite set, and you have these set of ordered pairs in this finite set. Okay, and here's the question. What can the value of x be? What can the value of x be so that this is not a function? What can the value of x be so that this is not a function? Okay, all right. So remember the definition of function. For each x coordinate, there's got to be what? Exactly one y coordinate. So she says 3.
It can't be 3, 2.
So what can the value of x be so it's not a function? Well, x can be what? 3. So if I put 3 there, do y'all agree it's not a function? Because when x is 3, what's my y value? -1 and what? 7. What else can you say? X cannot be 2 because when x is 2, y is 6 and what? 7. What else can't x be? Because when x is -4, I get 8 and what? 7. Can someone say this? Can someone say, well, if x is 6, it's not a function? No, because when x is 6, it is a what? A function. So you can't use this one. So do y'all agree that these are the only ones you can use?
Yes.
Okay. So when doing number 1 on this worksheet, you have, let me go ahead and, can you see it?
Yeah.
So here's my ordered pair. There are 4 of them. 2, -3, -1, 3, 6, 1, x 5. This time I have it multiple choice though. So you just tell me which of these numbers you cannot use. You circle the 1.
C,
No, it's D. Oh, wait. Okay.
C,
Yes,
C.
D.
All right. And then number 2, for the following relation, determine the domain and range. State the domain and range in interval notation. That was like we did last class period. Y'all see that? Okay. Number 3, determine the value given the determine the function value given the graph. So that's where you have to read from the graph. So if x is 1, you find what? Y. Okay. Don't forget the back. Then you have these: f of 3, f of 1, f of 4 from the graph. And then, okay, so now here, that means the same thing as what we just did here. So this is saying if x is what? -3, what is the y value? So same thing. Y'all agree? So when x is -3, what's the y value? -1. So you put 1 in the blank. All right? So remember, these are ordered pairs. These are function values. But they mean the same thing. So I'm making this up. So let's do f of 3. What's f of 3 here? -2. As an ordered pair, what would that be? 3, -2. And that's what this is. Okay? That's what that is. Okay, so that's this worksheet. So I'm going to go ahead and give this to you. So let's do 1 week from today. And now you can do my math lab on section 10.6. Okay? All right, now, so let's do one more for today. Okay, so we're done talking about functions and graphing for the moment. Now, most of what you're going to do at this point forward in this course is going to involve factoring. So we're going to start talking about factoring polynomials. So that's chapter 13. Chapter 13. All right, so chapter 13 is on factoring, and for almost everything after that point involves some kind of factoring. So you got to make sure you can master chapter 13. Now, a prerequisite for chapter 13, in order to be able to do chapter 13, involves something you did last semester. So let's talk about a couple of things that you did last semester. All right, so from last semester, if I had, and I'm not going to say the directions just yet, but if I had something like this, what did you do? Yeah, so usually the directions will say simplify this or multiply. Multiply/simplify. So if it just says simplify, simplify here means just get rid of the parentheses. In order to get rid of the parentheses, I'm going to use what property? Distributive property. And so that would be what? 6x minus 15. Okay? 6x minus 15. Number 2. 2x times 3x squared minus 6x plus 1. Now remember, you guys also remember this, when you multiply like bases, what are those exponents? You add the exponents. So what is 2x times 3x squared? This is what I have, 2x times 3x squared. 2 times 3 is 6. X times x squared is x to the third. Because when you multiply like bases, you add exponents. 1 plus this exponent here is going to be a 1. 1 plus 2 is 3. So you get 6x cubed, right? 2x times a negative 6x is negative 12x squared. 2x times a positive 1 is 2x. Okay? That's what we get. So what's going to happen when we talk about factors, you're going to be going backwards. So we're going to talk about the GCF either today or next class period. We're going to talk about the GCF. So last semester you were given this, you had to come up with this. This time, in this chapter, you're going to be given this, you have to come up with this. So you're going backwards. So you'll be given 6x minus 15, you have to come up with, if it says the word factoring, you got to come up with what expression? 3 times 2x minus 5. And you're going to see how to come up with that in a little while. It's not that difficult. This part right here is not that difficult to do, to factor. All right, 3. Negative 3x squared y times 4xy minus 7x plus 2y. Write that down first. So negative 3x squared y times those 3 terms, 4xy and a negative 7x and a positive 2y. All right. So if it says simplify, means get rid of the parentheses. Get rid of the parentheses here, you're going to do what? Distribute. So you're going to multiply everything inside the parentheses by the term that's on the outside, the factor that's on the outside. Okay, so here we go. Now, remember in your mind, now if you need to write things out, you write things out. So basically you're saying negative 3x squared y times a what? 4xy. So negative 3 times 4 is negative 12. So far I have a negative 12. Now do the x. What's x squared times x? X cubed. And now y times y is y squared. All right, so you agree with that part. So that's my first term of the answer. Now the next one. What's a negative 3x squared y times a negative 7x plus 21x what? Cubed y. Very good. All right, any questions before we go on? And then the last term, what's a negative 3x squared y times a positive 2y? Y what? Y squared. Because y times y is y squared. So that's last semester. This semester, you're going to have what's in the blank, and then you have to go backwards. You have to rise a product. So you're going to see how to do that. It's very simple to do. This part's going to be very simple to do. Okay? All right, so on this worksheet that I'm showing you, see it says multiply. You're going to use what property in all of these? Distributive property. So that should be easy for you. I don't see anything difficult for you to do. So all these you should be able to do. You see that? Okay? Just be a little bit careful when you have a lot of terms, because you got to see how this, that's an M and an N. So if you're not careful, you may think an N looks like an M. So just be careful. All right, I want the answer. So you do that. All right, now the other thing you got to remember how to do from last semester is this. 3x plus 1 times 2x plus 3. Remember how we did that? What did we use? Okay. The first thing you did last semester was talk about the distributive property. But at some point, you saw that when we multiply two binomials, we can just use what method? FOIL method. FOIL method. So first, outer, inner, last. Okay? Which is a version of the distributive property. But it's just an acronym. The FOIL method is just an acronym. It involves a distributive property, but it's an acronym for first, outer, and the last. So when we talked about F meaning the first, we looked at the first terms of each binomial. And we did what to those terms? Multiply them. So what's 3x times 2x? 6x squared. Now I need for you to know the FOIL method, because when we start doing problems that involve foiling, going backwards, knowing the FOIL helps. So you got to know how to use the FOIL method. The outer is the terms on the outside. So it's 3x times 3. 9x. Okay? I is for the inner. The terms on the inside. What's 1 times 2x? 2x. And then L are the last terms of each binomial. So 1 times what? 3 is 3. Okay, so that's where we're at. First, outer, inner, last. Then you recall that for the outer and the inner, you could do what to those two terms? Combine them. So what's the answer? Plus 3. So what's going to happen at some point in chapter 13 is you'll be given this trinomial, and you have to come up with this product of two binomials. That's what you have to do at some point. So that's called factoring. So factoring means to write as a product. So notice I wrote this trinomial as a product of what? Two binomials. So it's easy to go this way. It's a little bit more challenging to go this way. But it's doable. You can do this. So you can learn how to do this in this chapter. And every other chapter after that is going to involve some kind of factoring. Number 5. Suppose you had 3x minus 4 times 2x plus 7. So 3x minus 4 times 2x plus 7. All right, so what are you going to use here? FOIL. All right, so let's talk about first. What's going to be the first? Well, first of all, you're going to multiply what two terms to get the first? Okay, so it's 3x times 2x. Okay. The outer, what two terms will you multiply to get the outer? 3x and 7, what do you get? 21x. What two terms will you multiply to get the inner? Negative 4n, 2x, and what do you get? And then the last, what two terms will you multiply to get the last? And what do you get? All right. And then what's the next step you have to do? Combine like terms. What's 21x minus 8x? So what is it? 13x. Okay, so your answer is going to be 6x squared plus 13x minus 28. Is that correct? You all agree? Okay. All right, what about this one? 2x minus 5y times 3x plus 2y. All right, so 2x minus 5y times 3x plus 2y. So what two terms do I multiply together to get the first? All right, so what's 2x times 3x? I agree it's 6x squared? So that's 6x squared. What two terms do I multiply together to get the outer? 2x and 2y. What's 2x times 2y? 4xy. And let's put an alphabetical order. So xy, 4xy. Okay. The inner. What two terms do I multiply together to get the inner? And let's put an alphabetical order. So negative 5y times 3x is a negative 15xy. Because remember, 5 times x, same thing as y times x, same thing as x times y. And now the last, what two terms are multiplied together to get the last? Negative 5y and positive 2y. So what do I get? No, not x squared. Y squared. Right? Negative 10y squared. And now combining like terms, what's the answer? Yep. Negative 11xy and then minus 10y squared. Okay? So that's what you did last semester. Now, in this chapter 13, you're going to be given this trinomial that have those two variables in it. And you're going to have to come up with the two binomials, the product of two binomials. I'll be going backwards. Okay, number 7. All right, what about this? Remember how to do this? Yeah, so 5x minus 1 squared means what? 5x minus 1 times itself. 5x minus 1. And so you just use the FOIL method again. So what two terms do you multiply to get the first? Yeah, so it's 5x times 5x. What two terms do you multiply to get the outer? What do I get? Okay. What two terms do you multiply to get the inner? So you get negative 5x. Now, just remember like last time, whenever you square a binomial, what do you notice about the outer and the inner? They're the same. All right, and then what two terms do you multiply together to get the last? Which is? No, not negative 1. Positive 1. Combine like terms. 25x squared minus 10x, right? A negative 5x, a negative 5x, a negative 10x, and then plus 1. Okay? 8. 2x minus 3 times 2x plus 3. 2x minus 3 times 2x plus 3. What two terms do you multiply together to get the first? 2x and 2x is? Okay. What two terms do you multiply together to get the last? I'm sorry, the outer? What do you get?
Oh, 6x.
What two terms do you multiply together to get the inner? So I get? Okay. And what two terms do you multiply together to get the last? Which is? All right. What do you notice when you combine like terms? The out and the inner cancel out, so you're left with 4x squared minus 9. All right. Now, when we do factoring, you're going to learn, and it's towards the end of that chapter 13, you're going to learn that this right here is called the difference of two squares. So we're going to come back and talk about the difference of two squares towards the end of that chapter 13. So it turns out that when you factor the difference of two squares, I want you to notice this, and we'll talk about this next time. At the end of that chapter 13, you don't have to know this now, but what you're gonna notice is that when you factor the difference of two squares, the terms in the binomial are the same except for the middle sign. 2x, 3, and what do you notice? Signs are different. So that gives you the difference of two squares. So you can see how that's going to play when we get to that part. Those are the easy kind right here. Difference of two squares are the easy one to deal with. Okay, so in terms of this worksheet, this is what you're going to see. So make sure you can do this. You can do number 1. You can do number 2, the two variables. You can do number 3, number 4, 5, 6, 7, 8, and 9, and 10. You're going to write as two binomials first, and then use a FOIL. Okay? All right. So here, I'm going to pass these out. So this is due a week from today. Now, there's some videos on this. So when you go to Canvas,